In this video, I'm going to cover metamorphic processes and textures of metamorphic rocks. The learning goals include understanding what metamorphism is, what are typical metamorphic rocks, and what are typical metamorphic textures. So metamorphism, simple enough, it's subsolidus changes in minerals and textures in rocks. It may involve a change of chemistry. Fluids can bring chemicals in and remove chemicals from the rock during metamorphism. Metamorphism in general results from changing temperatures and pressures, typically taking temperatures and pressures to higher conditions. At the limits of metamorphism, you may have partial melt coexisting with rocks that are being metamorphosed. We need to define a few terms. Protolith, protolith, lith is rock, proto is early. Protolith is the starting material for metamorphism. Prograde is a statement that metamorphic conditions are increasing. Typically it means increasing the temperature. Retrograde is the process of decreasing the temperature, and it's the changes associated with decreasing temperature. So what are the limits on metamorphism? First of all, temperatures have to be higher than about 150 degrees centigrade. Below that, we call it diagenesis, and it's normal processes occurring during sedimentary lithification. The high temperature limit of metamorphism is the point at which the rock actually melts. And that temperature limit depends on what kind of minerals you have and whether there's water present. A nominal range is somewhere between 600 and 1,000 degrees centigrade. You can have a metamorphic rock that contains partial melt, and these are called migmatites. We use a qualitative label for metamorphism that's called grade. It's just simply a descriptive term with increasing grade implying increasing degrees of metamorphism. And increasing degrees of metamorphism means higher pressures and higher temperatures. We can schematically illustrate that on this diagram, and we'll be using this kind of diagram for all of our metamorphic talks. We'll put temperature across the horizontal axis, and we'll have pressure increasing as you go down, which is appropriate since pressures go up with depth, and I have a depth scale on the right going down to 30 kilometers, basically the base of the continental crust, and a pressure range going from 0 down to 1 GPa, the nominal pressure at the base of the continental crust. And you see the horizontal scale going from ambient temperature all the way out to 1,000 degrees. The range of diagenesis, normal processes within sediments, is in the corner, low pressure, low temperature. As you go to higher temperatures, we'd call this low-grade metamorphism, and it also includes going to slightly higher pressure. And here's an example of a low-grade metamorphic rock. It was a mud. It still has bedding and textures like the original mud. It has not been extensively recrystallized. Going to higher pressures and temperatures, you enter a regime of intermediate grade metamorphism. And finally, going all the way out to melting temperatures, we would have high grade metamorphism. Beyond that, it's a melted rock. Now, a rock right on that boundary between high grade and melt looks something like this. You see the stringers through this rock are magma, and in between is a high-grade metamorphic rock, a gneiss. So let's talk more about the textures, and we start with a protolith. And a typical protolith for metamorphism might be a mud that turned into a shale. And here is a shale showing original bedding as it was laid down on some lake bed. After it has been metamorphosed, it looks something like this. And in the metamorphic form, we would describe it in terms of its mineral constituents and its texture. This is a garnet, starlight, muscovite, schist. So 3 minerals, garnet, starlight, muscovite, and a metamorphic texture of a schist. Where's the garnets? Well, you can see I've circled one here. It's the equant isometric form, slightly reddish color. The starlight, well, you recognize those, the prismatic reddish-brown crystals. And finally, the muscovite, a ground mass of fine-grained mica crystals.